Here's a right angled triangle, and I've marked in the angle theta and the opposite, adjacent and hypotenuse. We know that sine theta is opposite over hypotenuse. We know that cos theta is adjacent over hypotenuse. Let's think about sine theta divided by cos theta. So that's O over h divided by A over h. If we're dividing fractions, it's the same as multiplying by the reciprocal of the second fraction. So that's OH over AH, O over R. The h's cancel, so therefore sine theta is over cos theta is O over A. But opposite over adjacent is tan theta. So from this we can see that sine theta divided by cos theta is the same as tan theta. Here we've got the same triangle again. So sine theta we know is O over h, cos theta is A over h. Let's think about sine squared theta plus cos squared theta. Well, sine squared theta, that means sine theta times sine theta, so that's O squared over h squared. Cos squared theta, that means cos theta times cos theta, that's A squared over h squared. They're both over h squared, so it's O squared plus A squared over h squared. But hang on, Pythagoras tells us that O squared plus A squared equals h squared. In other words, this equals h squared over h squared. H squared over h squared is 1. So from this we can see that sine squared theta plus cos squared theta equals 1. Now here we've got an equation, a trig equation, where it says sine theta is 0.342, and we know that theta is an angle between minus 360 and 360. So to solve these equations we need to use the graph of y equals sine x. So sine theta is 0.342. The first step is to use your calculator and do inverse sine of 0.342, and you get 20 degrees. So if you look at this on the diagram here, we know that at 20 degrees, which is round about here, the value of sine theta is 0.342. So that value here is about 0.342. So what we need to do is to think about this value here. This is 0.342. And what we've done just now is we've read off this value here to be 20 degrees. The point is there's other values for which sine theta is 0.342. And those values are here, and here, and here. There's also one there, but I don't need that one because that value there is over 360, and we know that the theta angles are between 360 and minus 360. So we need to find that angle there, this angle here, this angle here. And to do this we use the symmetry of the sine graph. From there to there is 20 degrees. So from there to there is also 20 degrees. So if this angle here is 20, that angle there is 20. In other words, this angle here is 160, because 180 minus 20 is 160. We also know that the angle from there to there is 20 degrees, which means this angle here is minus 200. We also know that this angle here is 20 degrees, which means this value here is minus 340. So the solutions to the equation are 20, 160, minus 200 degrees, and minus 340 degrees. And you can check that by putting that into your calculator. If you do the sine of 160, or the sine of minus 200, or the sine of minus 340, the answer comes out to be 0.342 every time. Here's a slightly more complex equation. Cos of 2 theta minus 20 degrees is 0.174, and this time theta is between 0 and 180. So we need to find 0.174 on this line here. It's going to be round about here. So let's draw that in. So the first step is to identify that point there, that point there, that point there, that point there. So from your calculator you can see that 2 theta minus 20 degrees do the inverse cosine of 0.174, and we get 80 degrees. But we've also got to consider this point here. Well, that point here we said was 80, so let's just write that in. So that's 80. So this gap from here to here is 10. So that gap from there to there is 10. So we then get that point there to be 280, this point here to be minus 80, this point here to be minus 280. So from here we can say we've got 80, 280, minus 80, minus 280. There are other values. They'll be over here or back here. For the moment, we'll just consider these. Now we need to add 20 to both sides, so 2 theta is 100, it's 300, minus 80 plus 20 is minus 60, minus 280 plus 20 is minus 260, so theta is a half of those, that's 50, 150, minus 30, and minus 130 degrees. Now it said that theta was between 0 and 180, so we don't actually need these values here. Were there other values? Just let's consider what would have happened if we had carried on further on up here. The next point at which the graph crosses the x-axis is at 450, so 20 before that would have been 430. So this next value after 280 would have been 430. When we add 20 we would have got 450. When we divide by 2 we'd have got 225, but remember theta is between 0 and 180, so we didn't need to do this. It's worth checking though to make sure I've got all the solutions.